Hey guys, this is Mr. Bennett, and I'm assuming you're on Thanksgiving break, and I'm trying to get better on meds, and anyways, needed to make this video for you guys, and here it goes. So video 7-3, transition metals. We haven't really talked about transition metals up until this point. We know their name, we know where they are in the periodic table, but up until this point, when we've talked about ions, we've talked about representative elements, meaning elements that fit into groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. 8A, remember, is where the octet is, right? That's where all the other elements are trying to get. And the reason why we've been able to do this is because they have predictable valence numbers. So, for instance, 1A has 1 valence electron. Magnesium, which is in the second group, 2A, has 2 valence electrons, right? And this means that when magnesium forms an ion, it's going to lose 2 electrons, and by doing so, it's going to look like neon, right? So its final electron configuration will look just like neon, which has an octet, and that's the goal. So our formula for a magnesium ion will be magnesium 2 positive because it lost 2 negative electrons. Now, again, this video is all about transition metals, so let's get into that. Transition metals, the reason why we haven't been able to talk to them up until this point is that their electrons can transition to other orbitals. In other words, they can take on different charge values. They're not predictable. So, for instance, iron, we can't say will always have exactly the same charge. There are different versions of iron ions. Let's give you an example here. Copper, another transition metal, has 2 possible charges. And to communicate which charge is present in any particular example, we use a Roman numeral. So for instance here, copper 1 has a charge of positive 1. Copper 2 has a charge of positive 2. So the Roman numeral is telling you the charge number. The reason why they're both positive is because they're metals. Okay, and whenever a metal forms an ion, it always forms a cation, right? Cats have pos, so cations are positive. So the Roman numeral gives you the number, but they're always going to be positive. And just to clarify, transition metals, we're talking about D block as well as under the stairs. So gallium, tin, bismuth, thallium, indium, and lead. Okay, so that section there, it's kind of a rectangle and a little triangle under the stairs. So this does mean that you need to know your Roman numerals, at least up until the number 5. So 1, 2, 3 are easy. It's just the number of lines. So 1 line, 2 lines, 3 lines. 4 and 5, you kind of need to know 5 in order to understand 4. So 5 is a V, and then for 4, you simply put a line in front of it. Think of it as 5 minus 1. Okay, I've got 3 practice ones here. See if you can pause it and write the symbol as well as what the charge should be. So pause it now and try it out. Okay, hopefully you pause it, you tried it out. First of all, you need to be able to find those symbols. Lead is over here. Lead is Pb. Okay, it's lead 2, so that means the charge number is 2, and these are all metals, so therefore the charge value is going to be positive. Tin, on the other hand, is Sn. Sn, it's tin 4, which means that the charge number is 4, and then the charge sign, or whatever you want to call it, will be positive, because again, it's a metal. Iron, last but not least, is right here. It's Fe, so this would be Fe, it's iron 3, so that means its charge is positive 3. Alright? Now, what happens if I don't give you the Roman numeral? In other words, what happens if I give you the formula unit of an ionic compound like this one? This is a lead oxide. But since I didn't give you the name, you don't have a Roman numeral to tell you what the charge actually is. How do we figure it out from the formula unit? Well, you start with what you know. First of all, oxygen is a nonmetal, which means it forms an anion, which means it's going to have a negative charge. Lead, on the other hand, is a metal, transition metal. It's going to form a cation, like we just said earlier, and that means its charge value will be positive in terms of sign, but we still don't know the number. Oxide, on the other hand, we do know the number, right? Oxygen is right here. It's in group 6A. We know that it needs to gain 2 electrons in order to get its octet, right? And we know that anything in this column, the oxygen column, will form a charge of -2, because when you gain 2 electrons, they each have a negative charge, right? You gain 2, you get 2 negative charges, and it gets its octet. So oxygen will always have a charge of -2. That means we can use that, okay, to figure out the charge of the oxygen. Well, how does that help? Again, start with what you know. we know that ionic compounds must have a total charge of 0. So that means that the charge of the oxygen plus the lead must add up to be 0. So if the charge of the oxygen is -2, we only have one oxygen, right? So total negative charge is -2. Lead, we only have one of those too. So lead, its charge is going to need to add up with -2 to equal 0, which means the lead must have a charge of +2, which means that this is lead 2. Okay, pretty easy? Well, we have a 1-to-1 ratio right here, so yeah, it should be pretty easy. Let's see what happens when we don't have a 1-to-1 ratio. Now, let me introduce a new method. So here's what I do when I want to solve these. First of all, I draw a line down the center. So I'm splitting my cation from my anion. Okay. Next, I draw a line across. Okay. Now, next step is I look at my chlorine, which is the nonmetal. That's the one that I know the charge of. Go over here. Chlorine is right here. Everything in this column forms a charge of -1. So chlorine's going to have a charge of -1. Now, I have my charge up here, and I know how many atoms or ions of chlorine I'm going to have. I have 3 of them. So if each one has a charge of -1, -1 times 3 ions gives me a charge of -3. So going down, I am multiplying. Okay. Now, we said just a moment ago that the positive side plus the negative side needs to add up to equal 0. And by multiplying downwards, I've taken the -1 charge of 1 chlorine ion, multiplied it times the 3 that I have, which gave me the total negative charge of -3. So that means that the total positive side, the total charge of the positive side needs to be +3, because 3 plus -3 will give us our 0. However, I need to know the charge of an individual iron ion. So what I do here is I figure out what the subscript is. In this case, it's a 1. We just have 1 iron, right? And instead of multiplying, because multiplying was going downwards, going up, I'm going to divide. Up is the opposite of going down, and dividing is the opposite of multiplying. So I simply take my +3 total for this side, divide it by the 1 ion I have, which means that I have an iron ion with a charge of +3. So this is iron, oops, I don't know why I put an I there, iron 3 chloride. Okay, so what I'd like you to do now is, using this method, solve the next 3. Okay, so you're going to pause it. Now if you get stuck, you can unpause it, watch a little further until you get unstuck, and then pause it again and try some more. Okay, but try to do all 3 by yourself. If you need to, start it up, watch me do the next one, and then try and do the second 2 on your own. So go ahead and pause it now and try. Did you try? Hopefully? Alright, let's do it. So first of all, I draw my line to divide it in half. This side is the positive side. This side is the negative side. Sulfur is the next column over from chlorine. So instead of forming a -1 ion, it forms a -2 ion. So we know that sulfide ions have a charge of -2. There's only one of them, that's why there's no subscript here. So -2 times 1 gives us a total charge for this side of -2. Now we know that the positive side needs to add up with the negative side to equal 0, right? So that means that the total charge of this side needs to be +2. There's only 1 iron ion, so I take my +2, divide it by the number of iron ions, which is 1, so 2 divided by 1, which gives me a charge of +2. So this would be iron, still iron, but this time it's iron 2 sulfide. Okay, perfect example of a transition metal. Same element, but with 2 different ionic charges, +2 versus +3. Alright, silver sulfide. So when I divide this one in half, be careful, because you want to make sure that you don't accidentally push this subscript over to the sulfur. The subscripts always follow the element that they describe. So in this case, the 2 belongs to silver. Okay, this side's going to be positive. This side's going to be negative. We already did the charge of sulfur. We know it's -2. There's only one of them again. So -2 times 1 gives us a total charge on this side of -2. We know it needs to add up with 0, or add up to equal 0 with the positive side. So the positive side needs to be equal but opposite. So in this case, it would be, instead of -2, it will be +2. Okay, and this is where dividing going up comes in handy. So this time, instead of having a subscript of 1 like we did with the irons, with the silver we have a subscript of 2. So that's 2 divided by 2, which gives us a charge of +1. That means that each silver ion has a charge of +1. We have 2 of them, so that's how we get the total charge of +2 over here. Okay, So the iron ion itself, though, or not iron, sorry, the silver ion itself, though, each of the two silver ions has a charge of positive 1. So we would call this silver 1 sulfide. Okay, and last but not least, the chromium down here. Here it's tricky. We've got two subscripts, one on each. So let's see how we do. First of all, this is the negative side, right? This is the positive side. Now we have our oxygen. Oxygen is in the same column as silver, or not silver, sulfur, so it has a charge of negative 2. Okay, we have 3 of them, so negative 2 times 3 gives us a total charge of this side of negative 6, right? Needs to add up to equal 0 with the positive side, so the total charge over here must equal 6. 6 plus negative 6 gives us 0. Now going up, we divide, so 6 divided by 2 chromium ions gives us a charge of positive 3 per chromium ion. We have 2 chromium ions, each with a positive 3, we add them together, 3 plus 3 is 6. Okay, just checking going downwards. So to write this out, we would write chromium. Sorry, my pen's getting very laggy. So that's chromium. The charge of 1 chromium ion is 3. Okay, and then we don't have to write this charge, we just write simply the name of the nonmetal, which would be oxide in this case. Okay, so hopefully you got that. Answer the questions on your whisk. If you haven't enjoyed Thanksgiving yet, gobble gobble. If you have enjoyed Thanksgiving already, we'll see you on Monday, and enjoy the rest of your weekend or whatever's left of it. See you guys soon.